Lesson 8.6, Day 2, Radical Expressions and Rational Exponents. The essential question is, how do I simplify rational exponents? Please write the essential question down now. A rational exponent is an exponent that can be expressed as m divided by n, where m and n are integers and n does not equal 0. Radical expressions can be written by using rational exponents. The exponent 1 over n indicates the nth root. The exponent m divided by n indicates the nth root raised to the mth power. And we're going to do some examples demonstrating this right now. What we're going to find is the denominator of a rational exponent becomes the index of the radical. Like right here, 8 to the 2/3. The index is the 3. We take the third root of 8, and then we square it. So for example, write the expression -32 to the 3/5 power in radical form. So radical -32. The 5 is the denominator. That becomes the index or the root. And we raise that to a power of 3. So what's happening is we're asking ourselves, what number raised to a power of 5 equals -32? That's what we're trying to solve in the yellow. Well, that is actually a -2. So what comes out of the yellow is a -2, and we're going to raise that to a power of 3. -2 to the third power is -8. Example 2, we're going to do in class. Let's try example 3. Write the expression 4 to the 5 over 2 in radical form. And simplify. Here's my radical. The 4 is the radicand. The 2 is out there. That's the root or the index raised to a power of 5. The square root of 4 is 2, and 2 to the 5th power is 32. Example 4, we're going to save for class. Now we're going to discuss some properties of rational exponents for all non-zero real numbers a and b and rational numbers m and n. Product of powers property basically states if you have a base raised to a power times the same base raised to a power, you are able to add the powers together. If you divide bases that are the same, you subtract their exponents. That's the quotient of powers property. A power of a power. You have a base raised to a power, you multiply the powers. Power of a product property states that if you have a product raised to a power, each piece of that product can be raised to the power. And if you have a power of a quotient property, that states that each piece of the quotient can be raised to the power. Let's look at example 5. Write each expression by using rational exponents. So now I'm going the other way. I'm starting with a radical and I'm changing it to rational. So the radicand is 3 raised to the 4 over 8. If I said 3, I meant 13. 13 raised to the 1/2. half. That's it. And B, we have 13 raised to the 15 over 5. That's 13 raised to the 15 divided by 5 is 3. 13 raised to a power of 3 is 2197. So I'm just going the other way, changing from a radical to a rational exponent. 6, we're going to do in class. 7, we're going to do right now. Simplify each expression. We have a base of 7 raised to the 7/9 times a base of 7 raised to the 11/9. The bases are the same, so we can write the base, and we're multiplying, so we add their exponents. So 7 over 9 plus 11 over 9, we get 7. 7 plus 11 is 18 over 9. Well, that's 7 squared, which is 49. Dividing. Bases that are the same. Grab the base, and we subtract. 3 over 4 minus 5 over 4. That's 16. To the 3 minus 5 is negative 2 over 4, which is actually 16 to the negative 1 over 2. But when you have a negative exponent like that, that's like 1 over 16 to the 1/2. Oh, well, that's really like 1 over the square root of 16, which is really going to be 1/4. And 8, we're going to save for class. Video questions, please write these in your notes. Write the expression in radical form and simplify the expression.